Good morning students. Today we will discuss a new topic, orbital velocity. What is orbital velocity? Orbital velocity. What is orbital velocity? Consider Earth having mass m and from origin its radius is capital R. If we put a satellite here around the Earth having mass smaller m, then it will revolve around the Earth in its orbit. So we will take its distance from here to here, height h. But its whole from radius to Earth and its distance will become r plus h. It is the radius of the satellite. Here is the satellite. So we can define orbital velocity. It is the velocity, orbital velocity is the velocity of a satellite which is required to move it in its orbit around the Earth is called orbital velocity. So we can write orbital velocity. Orbital velocity is the velocity of a satellite which is required to put the satellite in its orbit moving around the Earth is called orbital velocity. So we can denote it VO. This is the orbital velocity because we know that कोई भी पार्टिकल तभी मूव करेगा अगर वो सेंट्रीफ्यूगल फोर्स ऑब्जर्व करता है. किसी पार्टिकल को मूव करने के लिए सेंट्रीफ्यूगल फोर्स की आवश्यकता होती है. इट इज नेसेसरी फॉर अ पार्टिकल और एन ऑब्जेक्ट which can move around in a circular path which have a centripetal force. And here is the earth having gravitational force because there is a gravity on the surface of this earth. So we can see that gravitational force is equal to capital G m over r square. But here r is capital R plus h whole square, equation number 1. And centripetal force Fc, centripetal force is mv square over r. Here r is r plus h, this. But here is only r, mv square over r. Okay. And centripetal force is also r plus h because we will take here not only r but with respect to the radius of the earth and the satellite is r plus h. This is equation number 2. Now we can equal both the forces. Gravitational force is equal to centripetal force. F of G is equal to F of C. So it will become gravitational force is capital G m over r plus h whole square is equal to centripetal force. Centripetal force is mv square over r plus h. Here m is the mass of the satellite, smaller m. Okay, so power of this and this will cancel out, small m and small m. G m is equal to over r plus h is equal to v square, where v is the orbital velocity. Therefore v is equal to root of capital G m over r plus h. Okay, where gm is equal to small gr square, we can put the value of gm is equal to small gr square here, and h will become equal to 0. Why height will become equal to 0? Because if we put this satellite very close to the earth, if we take this satellite here, then there is a very little distance, very low distance, so height can be neglected, it can be 0. So V is equal to root G R square over capital R only. R and R is cancelled, root G R. This is the orbital velocity VO. This is the orbital velocity is equal to root G R. And if we put here value of G 9.8 meter per second square, value of R, radius of earth 6400 kilometer, then we will find 7.93 kilometer per second. This is the value of orbital velocity. It is very close to the earth. Its value is very close to the gravity.